Hi, in this video I'll explain a solved problem involving a collision between a block with another block having a spring attached to it. So if you see the definition of the problem, it's the same as what we saw in the animation. There is a blue block on the left hand side, it's moving towards the right at 2 meters per second, and it will collide with that spring which is attached to a brown colored block of mass 1 kg. We are supposed to find out the maximum compression of spring and the initial and final kinetic energies. Let's look at the animation once again. The blue block approaches the spring compresses, both the blocks start moving, and then the spring expands. So the maximum compression of the spring occurs at that instant when both ends of the spring have the same velocities, which means both the blocks are moving with the same velocity. Therefore, it becomes convenient to plug in a common velocity, V common or Vc, into the picture, and you can see that in the sketch. That will also help us apply the conservation of momentum. Initially, we find the kinetic energy of the blue block which is moving, which is half mv squared. So mass is 2, velocity is 2, so that becomes 4 joules. But we cannot find out V common without applying the law of conservation of momentum. So do m1 v1 plus m2 v2 is equal to m1 v common plus m2 into v common. That makes it convenient to solve the equation. We know the masses and the velocities. In the beginning, it was 2 kg and 2 meters per second on the left hand side, and the brown block was stationary, so velocity is 0, and on the right hand side we have 2 vc plus 1 vc. Solving that, we get v common equal to 4 by 3 or 1.33 meters per second. Now plug that into the final kinetic energies, so just do half mv squared for both the blocks. So we get half m1 into v common squared plus half m2 into v common squared, and that will give you 2.67 joules. So we have found most of the answers. The important thing is the loss in kinetic energy. We started with 4 joules of the blue block and landed with 2.67 joules of both the blocks put together. So where did the loss go? So the loss is 4 minus 2.67 equal 1.33, and that has gone into the spring. So the law of conservation of energy tells us that the loss of kinetic energy of the blocks went into the potential energy of the spring. So plug in the equation for the spring, which is half kx squared. So 1.33 joules of energy went entirely into compressing the spring, which is half kx squared. K is known, so we can find out x squared, and therefore we can find out x is 0.326 meters. I hope this solved problem is useful for you. Thanks and have a great day.